So this video is about solving absolute value equations as well as inequalities. So the first thing we want to do is kind of describe what is an absolute value. So the absolute value is the numerical value of a number without its sign. It can represent the distance on a number line, basically between a number and 0. So I have these two numbers here, so the absolute value of 3 and the absolute value of -3. And if I was just to draw a quick number line, right? 0, 1, 2, 3, -1, -2, -3. And if I start at 0 and I want to go to 3, right? I'm going to a little hop. So 1, 2, 3. So notice that it was 3 units. So I put a little 3 there, right? You can kind of tell that I already had that there. And then 0 to -3, again, 1, 2, 3, and it's still going to be 3 units. So no matter what is inside our absolute value, if it's a positive number or a negative number, the answer will always be a positive number, right? So knowing that, let's go ahead and solve absolute value equation. So here's our first equation. We have the absolute value of 3x minus 5 is equal to 16. So using the same concept as before, if I know the absolute value is the positive 3, it will equal 3. Same thing with the -3 equal 3. I'm going to look inside and I want to basically ask myself, when will the inside of the absolute value be a positive 16? And when will it be a negative 16? Because if I put that inside the absolute value, which I did right here, absolute value of 16 will be 16, and the absolute value of -16 will be 16. So what do? I'm going to focus purely on the absolute value, and I'm going to set up two equations. So one equation will be the 3x minus 5 is equal to the positive 16, which is right here, and the other equation we'll have it equal to a -16. Notice that I'm just changing what the equation is equal to. A common mistake is changing the x, making it positive or negative, or changing the 5 and things like that. So we don't want to do anything and manipulate the inside of the absolute value, just the outside. So I'm going to go ahead and solve this equation. So this add 5 to both sides. So 3x is equal to 21. Divide by 3, so x should equal 7. And then over here, I'm going to do the same thing. Add 5 to both sides. So 3x is equal to -11, and x is equal to -11 thirds. Again, you can keep it as your value. And I know that if I plug this in, if I plug a 7 in, so let's just quickly check our work. So if I say the absolute value of 3 times 7 minus 5. I want to make sure it equals 16. Well, 3 times 7 gives me 21. So 21 minus 5 does in fact give me 16. The absolute value of 16 is 16 because I already told you that right here. So we're going to do the same thing over here. We're going to check that number. So the absolute value of 3 times -11 thirds. Oops, pencil keeps breaking. And then minus 5. And I'm still setting it equal to the absolute value, right? And what it's equal to 16. Well, negative, the 3 and the 3 will cancel out, so I'll be left with a -11 minus 5. Still want to know if that's a true statement. So -11 minus 5 does in fact give me a -16. And I know the absolute value of -16 is equal to 16 because we said so right up there. Okay. So let's go ahead and try another one if you want to pause the video and try this one on your own. All right, so you should have set up two equations. So the first equation we're going to set up is a 2x plus 7 is equal to a 21, because I want to know when that's going to equal an absolute value of 21, because that'll be 21. And I'm going to say 2x plus 7 is equal to a -21. So again, notice I'm not changing anything. We'll go ahead and subtract 7 to both sides. So 2x is equal to 14. And x is equal to a positive 7. Over here, we'll do the same exact thing. Subtract 7 to both sides. So 2x should equal 28. And x is equal to -14. So again, two answers. And we can quickly check our work right here. So absolute value of 2 times 7 plus 7 is equal to 21. So 2 times 7 is 14. Keep that inside the absolute value, and the absolute value of 21 does in fact give you 21. Check on that. Over here, we'll say 2 times negative 14 plus 7. Close the absolute value up. Draw my absolute value signs a little bit larger. So this will give you a negative 28 plus 7. And that, in fact, will give you the absolute value of negative 21. And that does give you 21. Check. All right. So let's try one more. So here's our third example for solving absolute value equations. So go ahead, pause the video, take a moment. All right, so what's a little bit different about this problem is the absolute value of 4x minus 1 is equal to a negative 3. So remember, the absolute value of 3 is equal to 3, which we said earlier, and the absolute value of a negative 3 is also equal to 3. Our distance is always positive, which means can you ever have an absolute value equal to a negative? And the answer is no. So this is a quick no solution. There is no number that I'll be able to plug inside of x to get a negative value on the out when I plug in, once I do the absolute value. So this is a no solution. Okay. So we're going to take the concept that we just did in the first and second example, and we're going to apply them to inequalities. Okay. So here is our first absolute value inequality statement. Okay, and this time, now that we're back with absolute value and we're talking about inequalities, we will graph them as well. Okay, so we have the absolute value of x minus 2 is greater than 3. Okay, so my first suggestion when you guys are approaching these problems is to solve them like you just did on equations, right? We want to get those two numbers, and we can kind of think of the two numbers as like boundary points. So I'm going to say x minus 2, I'm going to drop my absolute value signs, and I'm just going to say it's equal to 3, and then over here I'm going to say x minus 2 is equal to a negative 3. Okay, go ahead and solve for this. So I'm going to get x is equal to 5, and I'm going to get x is equal to, what's plus, so negative 1. Okay, so these are kind of just the points, starting off points for your inequalities. So when I draw my number line, quick little number line, draw little arrows. So here's negative 2, negative 1, 0, 1, 2, 3, 4, 5. Barely made that in. Okay, now I want you to go back. Think about this. We have a greater than symbol. Notice that there's no line underneath, which means that these answers are not actually included. So if I plug this 5 in, 5 minus 2 gives me 3. 3 cannot be greater than itself. Okay, so that means I'm going to have an open circle at 5. And same thing with negative 1. Negative 1 minus 2 gives me negative 3. And again, the absolute value of negative 3 is 3, and it cannot be greater than itself. So again, I'm going to put a circle. So we have two circles this time. So I want to figure out, I have either two directions. I can either connect these 2 points together, which means every number between negative 1 and 5 is a solution, or, right, I'm going to basically draw my arrows out in opposite directions, and then every number less than negative 1 and every number greater than 5 is a solution. So it's always easier to test the points in between. So I'm going to pick one of the numbers in between negative 1 and 5. And I'm going to do a little test point. So test, we'll say test number. Right? So I'm going to test the number 0. So I'm going to say 0 minus 2 is greater than 3. Well, 0 minus 2 is negative 2. And the absolute value of negative 2 is 2. And is this a true statement? Is 2 greater than 3? No. Which means that none of these numbers should work. Okay? But just because we tested a number that didn't work, right, we want to test a number that does work. So let's try negative 2. So negative 2 minus 2. Testing that one out. So negative 2 minus 2 is negative 4. and the absolute value of negative 4 is 4, and 4 is definitely greater than 3, so I know that I am going in that direction. And I want to test one more point, so even though it's not on the number line 5, I'm going to test 6. So 6 minus 2 greater than 3, so this also will give me 4 inside the absolute value. Absolute value of 4 is 4, and 4 is in fact greater than 3, so I'm going to go ahead and go off in the opposite directions. So this is what my number line looks like. I want to write my answer in regards to this. So basically, I know that my numbers are going to be less than negative 1. So I'm going to say over here, I'm going to say x has to be less than negative 1, or the numbers have to be larger than 5. So x is greater than 5. All right, so this is an or statement. Now, how can we actually tell that this problem will actually always be an or statement? Okay, so I want you to remember that this problem was originally a greater symbol, right? Let's forget about proper spelling, but if you think of greater, change the E to an O, and it is a greater problem, or, which means that it's an or statement. So this could be a greater than or just a greater than or equal to statement, which means your answers are always going to go in opposite directions. Always that will happen, right? So it's a little hint in case you forget which way you should go. Okay, so let's test this out for another problem. All right, so let's try this example, number 2. So notice that this one is not a greater sign, it's a less than sign, right? So, so hopefully we understand that greater means it's going to be an or statement. So less than is going to be something a little bit different. So again, I'm going to set this up in two statements. So x minus 3 equal to a positive 21. X minus 3 is equal to a negative 21. Again, I'm just using this to get my two numbers. So add 3 to both sides, so 24. And then add 3, this should be negative 18. Now there's a lot of discrepancy between 24 and negative 18, so I'm actually not going to draw all those numbers out. Right? So I'll put negative 18 down here. Put 24 somewhere over here. Again, there's no line underneath, which means I have an open circle on both 18 and 24. So again, I want to test a point. Now, I love the point 0. So 0 is definitely in between negative 18 and 24. So I'm a little test point. So test number 0. So 0 minus 3 inside my absolute value is greater than 21. So 0 minus 3 is negative 3. And the absolute value of negative 3 is a 3. And that is a true statement. 3 is definitely smaller than 21. So I know that my answer 0 is included, which means every number in between these 2 points are going to be solutions. Again, we can test a point larger than 24. So we can test like 25. So 25 minus 3 inside your absolute value. That will give you 22. Absolute value 22 is 22. 22 is for sure not smaller than 21. So we know that our number is not going to increase past 21. Same thing if I tested number negative 19, right? It would not go past that direction. So how do I include all those numbers in between? Well, I know my number has to be smaller than 24, but it has to be larger than negative 18. So you're just writing a quick little inequality. So negative 18 is less than x, which is less than 24. Okay? So this is what we consider an and statement, right? Think of negative 18 and 24 almost like your bookends. So this is an and statement. This is an less than. So stretch your imagination. If you added a D to the end of less than, you would get an and statement, which means answers are in the middle of the two numbers. Again, it's just a little thing to kind of help you along in case you ever forget and you don't want to test out your numbers. So less than and statement, answers are in the middle. Okay, so now let's test these out with a couple more problems. So here's our first one. So you might want to pause the video and try this one out on your own. Okay, so I see that it is a less than and equal to, so I know that it's going to be coming together. So again, I'm just going to set it up as 2x minus 1 equal to a 5, and then 2x minus 1 equal to a negative 5. Add 1 to both sides, divide by 2. Do the same thing over here, add 1 to both sides. So negative 4 gives you negative 2. So here is my number line. So negative 2, negative 1, 0, 1, 2, 3. Okay, notice that there was a line underneath, which means 3 is included. And negative 2 is also included. So my answer should be in between these two numbers. So let's just double check. I'm going to plug in 0. Again, I like that number. So 2 times 0 minus 1 inside your absolute value, less than 5. So 2 times 0 is 0. 0 minus 1 is just negative 1, and negative 1, or absolute value of negative 1, is definitely smaller than 5. So that is a true statement, which means everything in between is a solution. So negative 2 and negative 2 and 3 are your bookends. So you are going to write them like this. X, negative 2 less than or equal to x, which is less than or equal to 3. And so again, when we're solving these, I do want to see, we do want to graph them, and we do want to rate them as an inequality. Again, test point would be helpful. All right, and why don't you try these next two problems on your own? So again, pause the video, take a moment. Okay, so we're back. Now the first question, right, we have an x plus 5 is greater than negative 1. And now if you think about this, okay, it has to be greater than negative 1. Remember, absolute value needs to be a positive number. So can an absolute, well, obviously an absolute value can be greater than obviously a negative number. But because there's a negative number here, we're going to see this as a no solution. Okay, there's no way to, we're not going to write our numbers. But if we see and look at number 5, right, I use the same numbers just a little bit differently. And so we're going to set up our two equations. So x plus 5 greater than, or not greater than. I mean, you can't put that there. I just like to write it as an equation. And then subtract 5. Subtract 5, so we get negative 4 and negative 6. So negative 6 comes first, negative 5, negative 4. Again, close circles at negative 6 and at negative 4. Okay, at this point, this is a greater, so technically my arrows should be pointing out in this direction. I'm going to test the point. So after negative 4 is negative 3, so I'm going to test that point instead. So negative 3 plus 5 greater than 1. So this will be 2, and 2 is in fact greater than or equal to 1. After negative 6 is negative 7. So negative 7 plus 5 greater than or equal to 1, which gives you negative 2, which is also 2. And that does work out. So what do we want to write? We want to say x is less than or equal to negative 6, or x is going to be greater than or equal to the number negative 4. Okay, so if you need any additional help on this, you might want to look back at some of your methods and meanings boxes and double check those those things on solving inequalities and solving your absolute values.